Let's look at a problem from section 5.2, where we will be using the definition of the definite integral to evaluate this integral. So definitely read section 5.2, look at the PowerPoint, watch the videos. Now I want to remind you of what we're doing. This theorem is on page 380. This is what we're using right here. So you have to pay attention to what is playing the role of A, what is playing the role of B. So in this case, A is -2, B is 0. So we have the limit as n goes to infinity of b minus a over n. Now we have the summation, I is equal to 1 to n. And in place of x, right, what are we doing? X is a plus I delta x, and I goes from 1 to n. So what's happening is if you want to think of this as an area, we're breaking up the area into smaller and smaller rectangles. So remember, this first term is x squared. See, for these types of problems, primarily we're going to be integrating polynomials, and that's it, because we can make use of some formulas, some summation formulas. Okay, so we have the quantity -2 plus 2 over ni, all of this squared. Again, where this is coming from, the -2 is the a, and 2 over n, that's the delta x. And the next term here is x. Okay, so expand this out. And we're going to combine like terms. And what you'll notice is that we get summation in terms of either a constant or some power of I. So we need to know that the summation of I from I is equal to 1 to n is given by this expression. Now that could actually be proved. It's an interesting problem. And what else are we going to need? We're also going to need, because this term right here, we need summation of I squared from I is equal to 1 to n, given by that. So where are we going with this? I'm using properties of summation. So what happens here if I add 2 plus 2 plus 2 to the n times, I'm going to get 2n. Because what is this telling me to do? Summation tells me to add, right? So this first term is 2 plus 2 plus 2, and you just keep track of where you are. You know, the index goes from 1 to n. Okay. So this 2 over n is still factored out here. So as we just said, 2n minus 6 over n. I'm using this formula. The summation of I from I is equal to 1 to n is n times n plus 1 over 2. That's where this is coming from. And then we have what? 4 over n squared times summation of I squared. See that? Okay, so as of this moment, it's like a chapter 2 problem. Limits at infinity, section 2.6 to be exact. Okay, and all you really, what you should realize is that each of these terms is a rational expression where the degrees of the numerator and denominator are the same. So all you really care about is the ratio of the leading coefficients. So you can work out the details that are missing here. The result is going to be 2/3.